Good afternoon, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe here at Hanover Fairground 2023. This is the first day of the fair, and as we say, this is the most important day of the fair because it's the fair, it's meeting new people, it's meeting new exhibitors, meeting new interests, partners, it's meeting new suppliers. It's basically meeting the potential and meeting the future. That's why we are all here at the group exhibition Hydrogen and Fuel Cells. I welcome you to have a drink. They are complimentary, so there are two lovely ladies walking around and serving you with a drink. So yes, just wave them down and you'll have a drink. Please come and have a seat. Yes, if you're walking around, because we're almost at the end of the technical presentations here at Hanover Fair. Our next topic will indeed be a little bit more technical. I'm also saying hello to our online guests who just tuned in for this talk. We are live streaming from the fair, and if you missed one of the talks, you can access them either through our YouTube channel, the website. I think we are also on social media this year. We are also growing, so just scan the QR code that is provided here in the audience. So, next topic will be how to leak test fuel cell and hydrogen-specific components. For that, please welcome with me on stage Head of Sales, Mr. Daniel Schönbohm of MACEAS.
Yeah, good afternoon. Welcome to our presentation. We will talk about leak testing today, especially hydrogen-specific components and parts in your production. So we are a typical mid-sized German mechanical engineering company, founded in 1995, 65 people doing all the job in-house. You can see two names here. It's Wortmann and MACEAS. Today it's just one. MACEAS is more or less a brand name. We started in 1995 with the development and design of ultrasonic leak testing equipment, especially exclusively for Volkswagen, in order to leak test their fuel tanks. And that was a start. That was a good business for many years. And of course, that was the past. And now today we are talking about hydrogen. This is why we are here. And so we switched over from fossil fuels, combustion engine components, to hydrogen components, battery components, and so on. So I will show you just the past. So this is the past. So we started with leak testing, and then it grew more and more, so there was that we delivered the complete production lines to the customers. Yeah? So we can see the mold there, coming where the fuel tank is coming out. And then from the first robot up to welding, assembly, leak testing, of course, and everything up to into the packaging or into the car. That was our delivery, the complete scope, the complete production line. That was the past, and now we're coming more to the future of our company. And if we're talking about leak testing, there are different technologies, how you can leak test a component. So you can see visual leak testing in a water bath or pressure difference, pressure decay. Of course, you can test with hydrogen, you can test with helium and with ultrasonic. This is something which is our unique selling point, this is ultrasonic leak testing. I will explain it a little bit later. But our core competencies are helium vacuum leak testing, the helium leak testing under atmosphere. That means helium sniffing or also helium accumulation. And as I said, the ultrasonic leak testing, which we can see a machine here. This is for the fuel tanks at VW, so where we test the tanks for leaks. And very important, we always combine it with fully automated solutions so that we can do the complete handling, the complete automation around the leak testing. So we'll explain the three technologies a little bit more in detail. So we have, for the helium vacuum leak testing, we have a chamber. We need a vacuum chamber where we put in the part. In this case, it could be a cylinder or whatever. Then we evacuate the chamber and we evacuate the part itself. Then we put helium into the part with a certain pressure, so always absolute. So we have an overpressure there. And if there's a leak, and there are always leaks, but it depends on how big the leak is, then we have a mass spectrometer connected to the chamber where we can detect the helium coming out of the part. And then the mass spectrometer knows exactly the leak rate of the part, and then we know part is okay or it's not okay, depending on the limited leak rate. advantage is you very quickly, you can detect very low leak rates, so very, very accurate. But you need a certain equipment which makes this a little bit more expensive than, for example, compared to an air pressure test, pressure decay test, and so on. But if you have low leak rate to detect, then it's a first choice. Oh. Yeah, and another solution would be the helium leak test under atmosphere. In this case, as this example, by sniffing with a robot. So we have also a chamber where we put in the part. Then we fill the part with helium so that we have an overpressure inside. Helium can come out. And if, for example, you have a welding seam, you go over the welding seam with your robot. The robot has a sensor on top, which is connected to a mass spectrometer. And then we can detect the helium coming out of this welding seam. So we exactly know where the leak is, but we are limited with the leak rate. So we're talking about 10 minus 4 millibar per liter per second as a limit, more or less. This is used for components which are not allowed, for example, to go into vacuum chamber or where you want to detect the leak where it is. And now we have these, as I said, the ultrasonic gas bar detection in the water bath, used for fuel tanks in the past, very much at nearly all OEMs. If you drive a Golf, for example, then I guess the tank is tested with our machine. And yeah, you put a tank, for example, into the water bath and fill it with air so that you have a certain overpressure inside the part. And then if you have a leak, bubbles coming out. That's usually there's a worker in front and seeking for the bubbles. But now we have this ultrasonic system above the tank. This ultrasonic system is detecting the bubbles, is counting the bubbles, is measuring the bubbles, the speed of the bubbles, and so on. And then we can calculate a leak rate. And the big advantage is, we can see it here, it's a red mark. We know more or less exact where the leak is. So you don't need a worker in front of the basin. You can detect leak rates down to 10 minus 3, 10 minus 4 millibar per liter per second. And you know more or less exact in the 2D top view where the leak is. This is something we have developed in the 90s. It is working very well today, and yeah, we are, I guess, more or less the only one on this planet who will deliver such kind of system. These are some examples which we built for high pressure tanks, for trucks, for the brake system. This is a helium leak tester with vacuum for cooling housings, small housings, very short cycle time, 6 seconds. We have different chambers inside, a lot of robot handling, conveyor system, packaging, everything in one compact cell, fully automated. This is another example for gearboxes in a helium vacuum leak tester with a big gantry system and 2 helium chambers and so on. And of course, helium is not endless. Helium is very expensive. That's why you need, on the one hand, you can mix it up with air or nitrogen, or you use a helium recovery system in order to get back more or less 90% of your helium you used for the process. Yeah, now we're coming to our future. Fossil fuels fuel tank was the past. Now we're talking about hydrogen and these components. So we have developed around about 3 years ago a modular system in order to leak test the bipolar plate of a fuel cell or electrolyzer, PEM electrolyzer. So it's a modular system. You can extend it up to your cycle time you want to have. Manual operation, fully automated operation, everything is possible. If you have one station, we're talking about a cycle time of 24 seconds. Then, of course, 2 is 12 seconds, and so on. So you can extend it to your capacities and your needs. And how does it work? So we put in one station, in one module, we put in 2 plates, 2 bipolar plates, and then we evacuate. Come on, yeah. So we evacuate the chamber itself. We evacuate all 3 circuits. And then we do a helium background check to get to know how much helium is inside. And then we fulfill the cooling circuit, and we measure the chamber, so the outside, and we measure the oxygen and hydrogen circuit in order to know where the leaks are. And then, of course, we have to evacuate everything. If everything is fine, then we do fill the oxygen circuit and test the outside and the hydrogen circuit. And then, of course, the last step will be the hydrogen circuit itself. And then if everything is fine, you can go to the next step, the next process step, and yeah, the leak test is finished. These are some examples. We already sold 7 machines. 4 machines are already running at customers in the USA, in Sweden, and we have 2 machines running in Germany. And it doesn't matter if they're metallic bipolar plates or they are graphite bipolar plates. We already did both of them. As I said, it's also possible to do it fully automated. So our customer Cell Impact in Sweden have this complete cell where we have robot handling and complete fully automated leak test cell in general. So with robot handling, conveying system, vision system, everything completed. Also, electrolyzers are interested for us. So we have built machines like a press in order to press a stack, to do the leak testing there. Single plates, part of a stack, a complete stack. So everything we can do here with this kind of press and leak test system. Another project which we are doing at the moment is a test stand which we have in-house for cryogenic tanks, where we do the vacuum creation of the insulation layer around the tank, and of course the leak testing. So we have to reach very low leak rates, 10⁻⁷ and lower, and of course a very low vacuum inside the insulation layer in order to have this liquid hydrogen inside cooled and liquid as long as possible. Yeah, that was a short presentation. Thank you very much. And yeah, if you want to know more, you can ask questions now, I guess, and later on in our booth E41. Yeah, it's no problem to visit us there. Thank you.
Thank you, Daniel. That was nice having you here. And yes, it's worth applause. Thank you for sharing all your details. There is a question from the audience that I will take immediately.
Okay, yeah, for sure.
What would you say is the clear advantage of your method against just pressurizing the fuel cell or electrolyzer to see if to use conventional hydrogen detector and etc. What is your advantage of your technology?
You mean the helium technology? So there's no advantage if you have to use the right technology for the certain project. Depends on the specifications you have, pressure, leak rate, and so on. So if you have a low leak rate,
can you give an example?
Yeah, if you have a low leak rate, talking about 10⁻⁻⁻ or 10⁻², then I guess it makes more sense to use in pressure decay, pressure drop, use air for testing because it's much cheaper. Helium needs in certain equipment, it's always, helium itself is expensive and the equipment is expensive. So, but if you have low leak rates like 10⁻⁵, 10⁻⁶ millibar per liter per second, then you have to use a tracer gas. Helium, or maybe also in the future hydrogen itself, yeah? Or as a forming gas, mixture of hydrogen and nitrogen. Yeah. Okay?
Thank you very much. Are there more questions from the audience? Yes, sir?
Hello, this is Carlo Poggi from Enapter. Just a question. In your systems where you did automated leak testing with helium, what was the cycle time of the machines?
Whatever you need, yeah. So for the bipolar plate, for example, so this one station, so there are certain limits in the physics. So we have a cycle time for the test of all 3 circuits, for example, of 30 seconds. Then 2 plates, then it's 15 seconds plus handling.
And this was done with helium?
There's a certain limit, as I said, for the physics, for testing and so on. Then you have to extend it to the stations, yeah. So you have to do more stations to go lower in the cycle time. Yeah.
Thank you very much. I also have a question, if there's none from the audience. So you see that there's already interest from the audience, and I would like to know this year at the fair, who would be your ideal customer? Who should approach you?
They're different. So on the one hand, there are the people, the companies who are producing the bipolar plates, for example, or tank components for hydrogen tanks, or tanks itself, and the companies who build the production lines. Yeah, both are possible. Yeah? The companies who build the products itself, or the companies who build complete production lines, because we are always one part of the production. Yeah? For the bipolar plate, for example, there's a stamping unit or press, then you have welding, and then you have leak testing. So we are quality assurance. It brings you nothing, but it is necessary. Yeah? It's important. Yeah.
All right. So I wish you a successful fair. It was
Thank
nice
you very
having
much.
you here. That was Daniel Schönbohm from MACEAS.
Thank you. Bye-bye.